for the drive so we can get. I forgot. It's math time, of course. What am I doing trying to play golf in the house? That's ridiculous. That's a little too cramped in here to try and actually swing a golf club. It's probably not a good idea. But a good idea is, again, welcome back for another day of math. We're ready for a little bit of action, but before that, the daily routine. Gotta get started with a couple things. Start with Disney pins. Why not? Up here we got a little Mike Wazowski. Oh yeah, Mike Wazowski. This Hollywood Studio pin. Right beside him, Pumbaa. Great animated sidekick. Just saying, easily top 5. Personal opinion, but it's right. But we gotta have an opening something. I got a Pokeball. Why? Because I found one. Why not? So let's see what's inside. Oh, sweet, we got Pokemon cards. Why not? And a chip of something. Of that. Do I know what this is? No, I don't. But you might, and you can let me know which Pokemon this is, because I have no clue. And a special shout out to Dane, who did know that the Little Mermaid from our last video is from the 4th Harry Potter movie. So great job, thank you. I appreciate the heads up. I like to learn a little bit too. Also, it's a card. You got a seal, but it's spelled wrong. It's weird. I'm not an English teacher, but I'm pretty sure there's supposed to be an A in there. Supposed to be a Machop. Oh, not only a Machop, we've got a Machoke. And who's this? Professor Kukui? Something like that. We got some fun stuff. Why not? All right. So we got our Pokemon cards. We've opened up something. And the Pokeball, which can go sit back up here. We'll leave the chip in there. Boom. Pokeball placed. Open up some. Oh, quotes of the day. It's time. First, our throwback quote of the day. It's from this past Friday. When I die, I want to go peacefully, like my grandfather did, in his sleep, not screaming like the passengers in his car. And our quote for today, I think is especially true. And many of you probably are living by this now with getting to the online learning kind of on your own time. The early bird can have the worm, because worms are gross and mornings are stupid. Yeah. I fully agree with that statement. All right. Quotes can go up here, hang out up top. One more thing before we get started. Grades are in, for those of you who are my students watching this, grades are in Skyward now. And so some of you are going to be really happy. And some of you might get in trouble with your parents. Just saying, if you haven't been keeping up with the work, I'm talking to you. No, not you. You. Behind you. That's the one. Get this stuff done. And if you help, again, email me. Let me know. We got to make sure we're getting all this material accomplished, because we're not only done with Part A now, we're moving on to Part B. And today starts some of those lessons for Pre-Algebra. Algebra, we're getting ready to do our second lesson from Part B. So I think that's it. I think it's time to get to the board. Okay, now, Magikarp, Slowbro, Raticate, Boldore. Pay attention. This is going to be on the quiz. Pre-Algebra guys, we're here. We're ready to go for another good math lesson. Today we're going to be talking about finding the distance between 2 points in the coordinate plane. Now, we have a distance formula, but we're going to be applying this a little bit with our Pythagorean theorem. That's been kind of the theme for the last couple of weeks on Edgenuity. So, we're going to find the distance between the points 3, 4, and 7, 10. We've already graphed it out. We've got 3, 4, 7, 10. We need to find the distance between those points. Now, we could use the distance formula. Just that the distance equals the square root of the difference in x values squared plus the difference of y values squared. So I'm going to go back to my problem here. We're going to go ahead and label these points. I like to label stuff because otherwise I forget. As you know, get a little scatterbrained sometimes. I'm not saying it's full distraction. Hey, Pepper, I'm just kidding. It's my dog. It's fine. So we're going to label the points x1, y1, x2, y2. Now what we're going to do is replace these values here, these variables here, with their corresponding values. So, come in. Distance equals square root of x2 is 7 minus x1, 3 squared, plus y2 is 10, y1 is 4 squared. Now I'm just going to do a little math here. So we're inside of our parentheses first. Again, distance is going to equal 7 minus 3, well that's 4 squared, plus 10 minus 4, 6 squared. Okay, so now we want to square those values. 4 squared is 16. 6 squared, 36. Add them up. Get the square root of 52. Well, that's a little bit bigger than 49, which is a perfect square. Square root is 7. So we could get our calculator out, but I already did that work ahead of time. Sit up book. The square root of 52 is approximately 7.2. And that kind of should make a little bit of sense. It should be a number close to 7 because 52 is really close to 49. Now that's one way of finding out the distance between 2 points on the coordinate plane, but we actually have another way we can do that. See, if I look at this line here, we've already connected it, already ready to go. I see something we could do. I'll get my handy dandy meter stick here. I could create a right triangle on the coordinate plane here if I did something like this. Look at that. We've got a right triangle, and we know something about right triangles. We know we can find the distance of the hypotenuse by taking the sum of the squares to the legs and taking the square root of that. So what is this length? Well, we count our units on the coordinate plane. It's 1, 2, 3, 4 would be the length of this leg. 6 is the length of this leg. We're trying to find our missing piece, in this case the hypotenuse. Well, we can use our Pythagorean theorem, which is a squared plus b squared equals c squared, and use that to find the missing length. 4 squared plus 6 squared equals c squared. 16 plus 36 equals c squared. There, we want to move our nice little COVID Mickey and Minnie's out of the way a little bit. 16 plus 36 is 52. Remember, we got to find out what c equals. We need to go from c squared to c. Well, that means we have to take the square root of both sides. So c approximately be 7.2. Holy cow, guys! It's the same answer. It should be the same answer. It's not a trick. It should be the same answer because, again, we're using just a different formula, a different way of getting to the solution. But this one might be a little bit easier for you, okay? So instead of having to remember our distance formula, we know we can create a right triangle in the coordinate plane and use the Pythagorean theorem to find that distance. So, pretty simple stuff. We're going to come back, we're going to do a little bit with the converse of the Pythagorean theorem. We talked about it before, but just a little refresher because there's a lesson on that coming up. And then we're done with math for the day. Sounds pretty good. See you in a second. Hey, give me 5, give me 5. Get up, get up, hey. No, up, 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 up. There we go, get down, get down. Bang, 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 bang.
Close enough.
That works. That'll make its way. Okay, we're back again. We've already talked about this a little bit, so if you want to see a more in-depth lesson, you can go back on the page, on my page on YouTube here. It's a wonderful site. And watch that video, but just a quick refresher about the converse of the Pythagorean theorem. Remember, we know a squared plus b squared equals c squared represents our legs of a right triangle. But if we know that we have a triangle, we have the legs of a triangle, we know the lengths, we can find out if it's a right triangle by using the Pythagorean theorem to prove it. So here, if I tell you I've got a triangle with side lengths of 8, 17, and 15, and we want to know, can that be a right triangle? We can use Pythagorean theorem for it. First thing I need to do is recognize which of these values is the biggest. Come on. It's not as 8, 17, which is the biggest number? Oh, okay, you got it. 17. 17 is our biggest value. That means if this is a right triangle, that would be my hypotenuse. So we have 8 squared then, the other two values, plus 15 squared. And I'll put a little question mark here, because we don't know if it's actually equal yet. We're trying to prove this. So let's do our squares. 8 squared, 64. 15 squared is 225. Does that equal 289? That's 17 squared. Again, if you're not sure what 17 squared is, over here a little vertical multiplication. 7 times 7 is 49. 7 times 1, 7, plus 4 is 11. 17 times 1 is 17. We add up, 9, 8, 2. Now it's added, 64 plus 225 is 289. Does that equal 289? Absolutely it does. Do one more, then we'll be wrapped up. 21, 11, and 18 are the lengths of the sides of a triangle. Is it a right triangle? Well, let's find out. Again, which one of these numbers is the largest? Which one's the biggest? Which one? I'm pointing to it. They're 21, yes. 21. So, if this is a right triangle, then 11 squared plus 18 squared will equal 21 squared. We're not sure yet, put that little question mark there just for the moment. 11 squared, 121. 18 squared is 324. 21 squared. It's not in our list that we had to learn earlier this year, so you two, again, do a little multiplication. 1 times 1 is 1. 1 times 2, 2. 2 times 1, 2. 2 times 2 is 4. 441. I can already see something here special, guys. This number ends in a 1. One spot's here. 1 plus 4 is not going to equal 1. In fact, it's going to equal 5. There. Does 445 equal 441? Absolutely not. So for this, as we look at this, we have not a right triangle. And over here, a right triangle. Yeah, again, make sure, guys, we'll be back for the closing in a second, but don't forget, guys, if you're not caught up, or if you're needing help, please let me know. I can't help you unless you help me help you. Help me help you, help me help you. Help me help you. All right, we'll be back in a second for the closing. Again, as always, coming together for math every day, every one of these times we do these videos. And even though we're going to do a family meeting later today, because it'll be family meeting time, which is going to make them cringe if they're watching this, because memories. Anyways, again, to my siblings, I'm going to point them out for you today. Anthony, Ross, DJ, get out of the way. We got to find Rebecca and Rebecca and Nelson didn't show up today. What? Stupid. I'm just kidding. I love y'all. I found them. They were hiding here behind Jim and Pam and Mufasa, because that's the thing. Hang out with the American flag. Hey, guys. How's it going? Cool. Again, more math, more algebra, another great day. I want to highlight here some other friends that showed up today. Say hello to COVID Minnie and COVID Mickey. Here, just to remind you, for the Outbreak 2020, wash your hands. Wash them. I know you learned it a long time ago, but seriously, wash your hands. It's gross if you don't. We're basking in some algebra glory here. Let's be real. It's pretty awesome. The son of the teacher of the universe, the Algebra 1 champ, here again for another day. Tomorrow's going to be another good one. So, all I'm saying is we'll see you tomorrow, but be ready for some more math. Get your work done. See you soon.